everybody. This is video C8, and it is a fundamental accounting principle review. I challenge you to, if you haven't already done it, turn off the video, try all the questions, because this is just review section. So you want to do that first, and then see if you can do it. I'm just going to put a question, start by question 3, because I realize it's a good question, but it's not exactly fundamental accounting principle. Okay, but you can try it anyway. I think the other ones are pretty straightforward. Okay, so I'm going to trust that you're going to pause the video and then turn it back on and go through it. All right. Robin is traveling to Vancouver and must choose one of the following methods of travel. She can take 2 different trains, 4 different houses, or 3 different planes. Trains, buses, or planes. How many ways can Robin get to Vancouver? Okay, I didn't realize it. This also is a bit of a trick question, because it's not like she's going to choose from the train and then get on a bus and then get on a plane. She's either going to take a train or a bus or a plane. It's going to be one of those choices. So I guess this is a fundamental accounting principle either, but it's a good question, because you know what? You're not going and the key here is that you're only doing one of them. You're not doing, like I said, a train and then a bus and then a plane. If you were doing that, then you know what? Fundamental accounting principle, straightforward. You would just multiply through. So this is the addition version of the fundamental. I read that the other day, but there's an addition version. But basically, we're talking about mutually exclusive cases. It's this one or this one or this one. So in that case, you add them up. And that's going to give you 9 ways. I'm feeling guilty. I put it on the question sheet. I want to look at it this way. There's 2 trains, 4 buses, 3 planes. Right, mutually exclusive cases, in which case you have, just like when from the last video, we were doing the parts with ending in different numbers, then we added up our totals instead of multiplying. Okay, anyway, how many positive even integers that, there's one of those killer words, killer phrases. Remember, less than, greater than, not equal to, at least. All of those, pay attention. You may end up doing cases. Can be represented using the digits 2, 3, 4, and 5. All right, well, let's start with the easiest. Let's go 3 digits. 1, 2, 3. And I got 2, 3, 4, 5. Oh, sorry. Hey. Okay, that part brought to you by Jelly Bean, my guard dog. Somebody walked by our condo. Anyway, so we need to be less than 500. So for it to be less than 500, can't have a 5 there. So that leaves me 3 choices, the 2, the 3, or the 4. Now, this question doesn't say anything whether you can repeat or not repeat. So if I got this question on a test and I wasn't clear whether repetition was allowed, okay, obviously the first thing you do is like put up your hand, hey, teach. Repetition allowed, not allowed, because it's not really stated. But if they wouldn't give me an answer, I would do the question both ways, just for practice, and then hopefully they'll just pick the right one. Make sure you label them. Okay, so if repetition is allowed, that means whatever number I pick here, I can now use And there are 1, 2, 3, 4 choices back left and 4 choices. All right. 3 times 4 is 12. This is going to be 48. And now I've got myself into a bit of a sticky wicket because I don't have much room. But this part reminds me that it's not only 3-digit numbers, but there's also 2-digit numbers that are less than 500. So here's my 3 digits. And I'm going to do my 2 digits. And I'm wishing I had left myself more room. Sorry. Okay. 2, 3, 4, 5. 2, 3, 4, 5. Now, if I start a number and it's got 2 digits in it, let's say I have 5 and then another 5, that's as big as I can get. That's still going to be less than 500. So all of my choices are going to work. So 4, any of those will work. Any of those. That gives me 16. And then my 1-digit numbers. 2, 3, 4, 5, and there are 4. And I feel sorry for whoever looks at my answer key because this is messy. So because we did this as cases, what do we do with our cases at the end? 16 plus, oopsies, I'll do that, 48. 16 plus 4. 64, 58 plus 16 plus 4. All right. There is my final answer. Now, if we don't allow repetition, it's going to be slightly different. Okay, so again, because it has to be less than 500, I can't use the 5 the first round. That's going to give me 3 choices. So let's say I use the 4, so then one number is gone. But I can now use that 5 in the second spot, just like the 0 before. So I got 1, 2, 3 choices left. Okay, now let's say we used up the 5. That's gone. And that's 2. So 3 times 3 times 2 is 18. Okay, I'm already running out of room. Okay, so we've got, there are my 3-digit numbers. Two, 3, 4, 5. So I can pick any of those in the first spot. So it gives me 4, 1, 2, 3, 4. Because any 2-digit number I make, no matter what, it's always going to be less than your 500. And the difference here, I can't repeat. So let's say I use the 3. So it's going to be 3 there. And it makes sense, right? There's going to be slightly less. When repeats were allowed, we had 16. Now I've only got 12 because we can't use some numbers like 22 and 33 and 44 aren't allowed. And then we need 1-digit numbers. And that's 2, 3, 4, 5. And there's 4. So our total, just like before, you can't have a 3-digit number and a 2-digit number at the same time. So that's going to be 18 plus 12 plus 4. 44? Ooh, 34. Oopsies. So you're going to have less. And there we go. Okay. So number 3 I started for you. You have to think this one through. So it's, imagine there's 12 people in a room. Got it? Okay, so the first person is going to start shaking hands. Okay, how many people will the first person shake hands with? Hold on, I want to get something. Okay, so again, I'm back, obviously. Yeah, 12 people in a row. The first one turns and he's gonna start shaking people's hands. How many is he gonna shake? Well, he's gonna shake everybody else. There's gonna be 11 people. Okay, he shook everybody's hand. Now the next person, so we're gonna call him person number 11. He has already shook hands with the first person, so we don't have to worry about him. But he's now gonna go down the line. And he's gonna shake how many people's hands? How many people are after him in the line? You get it? 10? Okay, so now we got person number 12, sorry, number 10. She's already shook hands with this one and this one. She doesn't have to do that. Gonna turn and she's gonna shake hands with 9 people. I suspect you can figure this out because it's just gonna keep going. So 9, 8, 7, 6, 5, 4, 3, 2, 1. Those are all my peoples. And they're going to shake hands with 8, 7, 6, 5, 4, 3, 2, 1, 0. Right? Because that very last person, they've already shook everybody's hand. They don't have to turn and take anybody's. Now, they weren't, how do I explain this? We just did this by cases. So we get to add up all those numbers, and there is no funky magical button on the calculator to do this fast. And the answer there is 66. All I can say on this one is watch for handshake questions. I don't have a really good way to explain how you know you should do this, but if you did it the other way and you multiplied all those numbers, it would be, hold on, I do have a fancy way to do that. Be like 39 million handshakes. And I would think when you do the question, if you got an answer of 39 million handshakes, you'd go, no, that can't be right. So sometimes it's a matter of doing it wrong and then realize that's not a plausible answer. All right, let's try the next one. Number 4, tennis pie. Okay, here we go. She gets to do one thing. She can buy ice cream, or she can buy sherbet, or she can buy frozen yogurt. How many ways can she choose a single dessert? Exactly like that first question. So she can choose this, or that one. It's not, I get to choose an ice cream, and then I get to choose a sherbet, and then I get to buy some froyo. No. It's or. So with or, it's going to be adding. So 20 plus 8 plus 5 is 33. Okay, and that's again, because we're looking, if we were doing a diagram again, these are mutually exclusive. She can do ice cream, or she can do sherbet, or she can do Froyo. But she's not doing this one and that one and that one. Okie dokie. Next one, 3 different colored dice are rolled. How many ways can the dice show up? This is a nice, straightforward question for us. All right, so we're rolling regular dice, 6-sided dice. And, well, how many sides? It's got 6. And what happens on that first dice is going to have absolutely nothing to do with what happens on the second dice. So that's going to be another 6. What happens on the third dice is going to be another 6. So that's where the 216 comes from. This part, whether you noticed it or not, is important because if they were all the same color, then a 2 on the first die and, oh, you know what, I'm not going to make, we'll get into this later with combinations. But because they're different colors, then it's just straightforward. Stop making things complicated for us. All right, last one. I didn't even have room on the page for it. Whoops, doesn't work if I make it go away. Okay, I'm going to do it on paper. All right. We're going to use all letters in the word hexagon if there are no restrictions. And I'm going to say right now, usually when it's using the letters of a word, you assume it's no repeat, so I'm just going to clarify that. All right, so A, 1, 2, 3, 4, 5. Whoopsies. 1, 2, 3, 4, 5, 6, 7. Yeah. 6, 7. So there are absolutely no restrictions. So I can use any of the letters the first round. So that's going to be 7. And then one of them disappears. You know what the answer is, right? 6, 5, 4, 3, 2, 1. You can multiply that through. I'm going to use, oops, can't see it, my magic button. This lovely factorial button on the calculator, which does it in one step for me, and it gives me 50, 40. Ta-da. Okay, so B, now it's going to start getting fussy. 1, 2, 3, 4, 5, 6, 7. It has to start with an H in my instructions first and end with an N. So in the word hexagon, there's one H and there's one N. And then we've got all the other letters. So all the other letters get stuck in the middle. So this is gone, which leaves us 1, 2, 3, 4, 5. Oh, you knew that, right? And then we can't repeat. It's going to be 5, 4, 3, 2, 1. You always put in your restrictions first, and then worry about arranging everything else. $120. So 5 times 4 is 20 times 6. Yeah, it's 120. All right. The middle letter must be an X. There's one X in hexagon. So that's gone. Scribble it out, which leaves for the other blanks 1, 2, 3, 4, 5, 6. You knew that, right? There's 7 letters altogether. We can't use the X, so this is going to be 6. And then you use 1 and you're going to count down 5, 3, 2. And if you do that, that should be 720. There we go. All right, D says we're going to start with a consonant and end with a vowel. So our consonants are 1, 2, 3, 4. We're going to pick one of those 4. Again, we're going to do those restrictions first. Vowels, we've got 1, 2, 3. Okay, so we've used up 2 of our letters, which should leave us 5 left, right? So let's say we use the H and the E, which leaves us 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. I always feel confident when it says use all the letters in a word and you're doing the countdown part because I know it repeats and you count down to 1. That usually tells me we did it right. So this is 4 times 5 times 4 times 3 times 2. I know I did that backwards. Times 3. Okay. I don't trust myself. 4 times 5 times 4 times 3 times 2 times 1 times 3. Yeah, okay, 1440. There we go. Now E, consonants and vowels must alternate. So 1, 2, 3, 4, 5, 6. Consonant, vowel, consonant, vowel, consonant, vowel. Oopsies. 1, 2, 3, 4, 5, 6. Aha. Pardon me for a sec. Hey. No. Sorry about that. Jelly bean keeps things entertaining. All right, so here we go. Last one. There are 1, 2, 3, 4 consonants. So 4. And I'm going to do all the consonants, and then we'll turn around and do all the vowels and hopefully it'll work out. So if I have 4 to begin with, so 1, 2, 3, 4, and then I'll have 3 and 2 and 1. Okay. Then we're going to do the vowels, and there are 1, 2, 3. That's going to be 3, and then I use up 1, which leaves me 2, and then I use up 1, that leaves me 1. 4 times 4 times 3 is 12, times 3 is 36, times 2 is 72, times 2 is 144. All right. Now, here's a hint. I'm overthinking, but I just want to make sure if I tried to 1, 2, 3, 4, 5, 6, 7, if I went like this, right? If I tried to do that, it'd be 3, 2, 1. Yeah, okay, that's never going to work for you. So that tells me there's not enough vowels to alternate that. I know there was a question with arranging boys and girls in alternating order. Can't remember what the question that was or what video that was in, but there was actually the 2 options, but that was because there was equal number of boys and girls. Here we do not have equal number of consonants and vowels. So, oh, I guess the question is, in how many ways can you arrange starting with vowels and alternating? The answer would be 0, because there's not enough of them. But I forgot to put the question. So, end of the video. Thank you. Have a lovely day.